You're walking down an empty street at night. A stranger appears 50 feet ahead. Your heart rate spikes. Your palms go damp. Nothing has happened yet. Nothing is even likely to happen. But the real answer for why your body reacts this way is far stranger than you think. It's not really about that stranger. It's about a version of you that existed 200,000 years ago, standing in the same kind of darkness. Except back then, the stranger usually did want something. Your blood, your food, your territory, your life. That ancient alarm system never got the memo that the world changed. Inside your skull sits a small almond-shaped cluster of neurons called the amygdala. It's about the size of your thumbnail. It doesn't think in words. It doesn't reason. It just watches for threat. And when it spots one, it hijacks your entire body before your conscious mind even catches up. Neuroscientist Joseph LeDoux spent decades mapping exactly how this works, and what he found was unsettling. Fear signals can travel from your eyes to your amygdala and trigger a full body response in under 12 milliseconds. That's faster than you can form the thought, is that dangerous? Your body already decided. Your mind is just catching up to its own decision. So why would evolution build something this twitchy, this reactive, this seemingly irrational? Because for most of human history, hesitation was the thing that got you killed. Picture your ancestors on the African savanna, roughly 200,000 years ago. No walls, no locks, no police 3 minutes away. Just open grassland, scattered trees, and predators that could outrun, outclimb, or outmuscle a human in almost every category. Lions hunted in coordinated packs. Leopards dragged prey into trees. And other humans, from rival bands, were sometimes just as dangerous as the lions. A 2007 analysis led by Harvard primatologist Richard Wrangham found something that still makes people uncomfortable. Lethal violence between human groups wasn't a rare aberration in our evolutionary past. It was common enough to shape our biology. The humans who survived long enough to have children weren't the calm ones. They weren't the trusting ones. They were the ones who treated an unfamiliar face as a possible threat first and a friend second. Your nervous system is the inheritance of the suspicious ones, not the friendly ones. Here's where it gets stranger. You'd think, after thousands of generations of agriculture, cities, laws, and cameras on every corner, this system would have softened, updated, caught up with reality. It hasn't. Stanford neuroendocrinologist Robert Sapolsky has spent his career studying why human stress responses misfire so badly in the modern world. His research shows that your body cannot tell the difference between a lion in the grass and a stranger on the subway, an angry email from your boss, or a red notification bubble on your phone. The hormonal cascade is nearly identical. Cortisol floods your bloodstream. Your heart rate climbs. Blood gets redirected away from digestion and toward your limbs, preparing you to run or fight something that, statistically, is not actually going to attack you. Sapolsky calls this one of the great tragedies of modern psychological stress. You're using a threat detection system built for immediate physical danger to process problems that are slow, abstract, and ongoing. A zebra's stress response shuts off the moment the lion is gone. Yours doesn't. You carry it into the elevator, into the meeting, into bed at 1 a.m., staring at the ceiling. So why hasn't natural selection fixed this? Because evolution doesn't optimize for comfort. It optimizes for survival long enough to reproduce. A nervous system that triggers 100 false alarms but catches the one real lion still wins, generation after generation. A calmer nervous system that misses even a single real threat doesn't get the chance to pass itself on. False alarms are cheap. Death is expensive. That math hasn't changed, even though almost everything else has. There's a deeper layer to this, and it has to do with numbers, not predators. British anthropologist Robin Dunbar spent years studying primate brain size in relation to group size and found a striking pattern. The bigger an animal's social group, the bigger the brain region responsible for tracking relationships. For humans, Dunbar calculated a number that has since become famous, roughly 150. That's the upper limit of meaningful relationships your brain evolved to track. Not acquaintances, not faces you've scrolled past. Actual relationships where you know who someone is, how they'll behave, and whether you can trust them. For nearly all of human history, you lived inside that number, a band, a village, a tribe. Everyone you encountered was either inside your circle of 150 or they were an outsider. And outsiders were a coin flip. Sometimes they brought trade, alliance, even marriage. But sometimes they brought raiders. Your ancestors who survived were the ones whose bodies treated unfamiliar faces with caution until proven safe. Now think about your actual life today. You pass hundreds of strangers before lunch. You scroll past thousands of unfamiliar faces before bed. Every single one of them registers somewhere in your ancient threat detection circuitry as an outsider. Not because your brain is broken, because your brain has no idea it's living in a species of 8 billion people instead of a village of 150. It's still running village-era software on a planet-era population. That's the strange answer the opening question pointed to. The reason your heart rate spikes around a stranger at night isn't really about that specific person at all. It's about every stranger who ever existed, compressed into one ancient, blunt instinct, still firing exactly the way it fired for your ancestors crouched in tall grass, watching the tree line for movement. Here's the part that should change how you think about it. This system isn't a flaw. It's not anxiety you need to eliminate or willpower you're failing to use. It's an inheritance. It's proof that somewhere down a chain of thousands of generations, every single one of your direct ancestors was cautious enough, alert enough, suspicious enough to survive long enough to pass that exact trait on to you. You are, quite literally, built from the genes of the ones who didn't get eaten. That doesn't mean the system is always right. It misfires constantly in a world this safe, this crowded, this digital. It treats a slightly too long stare from a coworker the same way it once treated a circling predator. It treats silence from a friend's text the same way it once treated a rustle in the grass. But understanding where the alarm comes from changes your relationship with it. You're not weak for feeling your pulse jump around a stranger. You're not broken for lying awake, replaying a tense conversation. You're running code that kept every single one of your ancestors alive in an environment that no longer matches the one it was built for. The next time it happens, the next time you feel that flicker of unease walking past someone you don't know, you don't have to fight it or be ashamed of it. You can just notice it for what it actually is, not a verdict on the stranger in front of you. A 200,000-year-old echo, still standing guard at the edge of the firelight, still watching the tree line, long after the lions left and the grasslands turned into sidewalks. You're not walking down an empty street at night. You're walking through deep time, wearing a body that never stopped expecting the dark to be dangerous.